Hello and welcome back to my channel. Today we are here with something very new, uh, interesting and simple. Perfect, friendly and life partners. Till I'm talking about numbers and their metamaths. Relax. This is not mathematics, neither a puzzle nor even a game. So I call it metamaths. Here is a disclaimer that I will give. That metamaths actually is a branch of mathematics. To study the mathematics itself in terms of or using the mathematical tools. Or metamaths refers to sometimes some computer language. But here I am using metamaths in the sense parallel to what you know as metaphysics. So let us quickly see what metaphysics is. So the disclaimer goes like that metaphysics is the study of reality and existence. Questions like who we are and what our purpose is, etc. And all these things are coming after works about nature, that is physics. They were titled metaphysics or after physics. Later on, it was interpreted metaphysics as meaning the science of things transcending what is physical or natural. Okay. So in my case, if you replace the word science from here and physics from here by the word mathematics, then we can call that coming after works about nature mathematics, it is titled metamaths, or here it can be interpreted as meaning the mathematics of things transcending what is physical or natural. So our job is to interpret some of those philosophically intriguing questions or similar questions, but in mathematical language. Okay, so let's proceed. We start with a number n, a positive n, and suppose that d1, d2, d3, etc. are its divisors. Okay, say for example n equal to 6, then d are 1, 2, 3, and 6. Right? So they are the divisors of the number n. Now let us define a new term s. Sum is for sum of the divisors. That is d1 plus d2 plus d3 plus etc. Of course, excluding n, the 6 here, n, it is obvious that 6 would be the divisor of 6. That's why it is included, excluded and marked red. Okay. So what we get is here for n equal to 6, 1 plus 2 plus 3. So that is equal to 6. So interestingly, the number itself is also 6. And that's why now we are defining an index called perfection index P as n by s, the number itself and the sum of the divisors of the number s, n by. And in this case for n equal to 6, as we have got s also 6, so it is 6 by 6, 1. So P perfection index is 1 for number 6. Okay. And that's why we call it perfect number. So perfect number is defined as the numbers for which P equal to 1 or n by s equal to 1 or n equal to s. Perfect. In our example, we have already seen that n equal to 6 is a perfect number. Another example, if we want to check, 28. Now you see the divisors of 28, 1, 2, 4, 7 and 14. As usual, 28 itself is excluded. So the sum of this divisors is 1 plus 2 plus 4 plus 7 plus 14, and that is 28. Okay, and that is nothing but the number. So we call that 28 is also a perfect number with P equal to 1. And we can check, is there any other number between 6 to 28? And you will be surprised to see that no one is perfect between these two. Okay, so this is my first concept, perfect number. Now we are going to another concept term, friendly numbers. Now let us focus on a couple or more of numbers. Because if you are talking about friends, that means at least you need two persons, right? Two individuals. Suppose start with two numbers n1 and n2. n1, it has its characteristic sum of divisors, we call it s1, and it has also p1. Similarly, the second number n2, it has its s2 and p2 as well. Now, suppose that n1 and n2, no one is perfect. That means p1 and p2 are not equal to 1, both of them not equal to 1. But the question may be there that is it that p1 is equal to p2? That means n1 by s1, is it equal to n2 or by s2? And if the answer is yes, then the pair of numbers n1 and n2 are called friendly. That means the perfection index, they have the same, though they are not perfect, not equal to 1. And to note that 6 and 28 each is perfect, that means p is 1, so p1 and p2 are 1, both, so they are equal. That means these two numbers 6 and 28 are perfect numbers and are friendly also, right? Because they are same by definition. But the reverse may not be true. If two friendly numbers, they may not necessarily be perfect. That means p1 equals to p2, but they are not equal to 1. Okay. So let us take an example. n1, first person, 30. So the divisors are like this. So if you sum up 1 plus 2 plus 3 plus 5 plus 6 plus 7 plus 15, you will get 42. Well, so what is the perfection index? P1. So it is n1 by s1 for the first person. So it is 30 by 42, that is 5 by 7, which is of course not equal to 1. So it's not perfect. Similarly, we have taken another number n2, 140, and again you find out the divisors and you sum up, you will get the s2, and that would be 1. Again, you will see the perfection index for the second number for the second person is again 140 by 196, 5 by 7, and not equal. But they are same, p1 and p2. They are same, 5 by 7, but not equal. So they are not perfect, but they are definitely friends, right? So 30 and 40 are friendly, but individually not perfect. So here gives a message that to be a good friend, you need not be a perfect person, right? Still you can be a good friend. Now I am talking about Metamaths. Actually, it starts with Tolstoy. You see the quotation from Tolstoy. A man is like a fraction whose numerator is what he is, that means the number itself, and whose denominator is what he thinks of himself. So here I consider that S, because S is the sum of the divisors, and divisors are like the components of your character. So that means as you think yourself, what you are, you think, that can be taken as the S. Now obviously if n by s is the ratio or fraction, then the larger the denominator, that is s, smaller is the fraction. Okay. So if you think yourself to be a very big person, but actually you are not, then actually your fraction value is much less and you are far away from your fraction. Right? So that is the mathematical explanation. Now being perfect in this spirit, what does it mean? Tolstoy defines U as a ratio P, n by s. Okay. So the more one is aware of one's true self. So if you really know what you are, what's the purpose of you to be here, as to be born as human being, etc., etc., that means you are very aware of yourself and you are very true to yourself, right? So the more one is aware of one's true self, S will approach towards N, and hence P will approach towards P. That means the person would approach towards perfection. So my conclusion is that a human being who is true to oneself is perfect. Okay. So it's a bit philosophical conclusion, but I am talking mathematical language. And obviously, we all are differently imperfect, having a versatile range of perfection index between 0 and 1. Fine. Now, being friendly, what does it mean? So, as two imperfect numbers having p values as p1 and p2 are same but not equal to 1 are friendly, we conclude that friendliness is synonymous with equality of perfection or imperfection. Because if p is perfection, then 1 minus p is imperfection, right? So either you can call it equality of perfection, or as well you can call equality of imperfection. That is the friendly. Well, my last concept is being partners, life partners, amicable. So a heart sign is there. Jadidang hidayan kabo, tadidang hidayan. So let us see partners. What kind of person partners are? They find the meaning of life in just doing for others, whose happiness lies in others' happiness. And for doing so, one need not be either perfect or perfection-based equality or friends. Perfection-based, equality-based friends. Even then, they can be good partners. How? How would we translate this kind of life partnership in terms of our so-called metamaths? Let us see. Of course, we need an index here also. We call it life partner L. And this time, which mixes up one with the other, taking together, because we are talking about couple of persons, right? So that means I demand that S of you and N of the other person, your partner, and S of the other person with N of you. So I am mixing up the qualities, the number value and the sum of the divisors, mixing. It's a kind of projection of one person onto another, right? So my demand is that if N1 equals to S2 and N2 is equals to S1. You can remember that in case of friendly or perfect concept, we define the index on the individual basis for a given person, not for a couple of persons. They are not mixed up. Okay, for friendly, for perfect, it is the individual index, and we did not compare even with other person p value. And in case of friendly, we calculated p individually and then compared. But here, when we define or evaluate the index, then it is mixed up. It's not no more individualistic thing. Okay, so it will be even more clear. So now we are ready to define the partnership index L as L1. Two persons involved, so L1. It is N1 by S2. You see, not S1. And that is equal to 1 because N1 equal to S2 that we have started with as the definition. And L21 is N2 by S1, not S2. Right? So they are mixed up. And that is again could be 1 into S2. So we can compare that in case of perfection index, we needed some ratio like N1 by S1. Both were 1, but here 1 is 1, another is 2, 1 is 2, and another is 1. Okay. So the definition goes like L12 and L21, they are same and equal to 1. Then we call N1 and N2 are amicable, are like partners. So I am sure you have already got the name, that kind of number. These are actually called amicable numbers. So let us see an example quickly. Suppose the number is 220 and S1, if you see all the divisors, you can check on your own. You will see that summation would be 284. Now, N2 is another number, 284, and S2 is interestingly 220. So here it seems that N2 you have chosen deliberately equal to 284. Yes, deliberately, but there is no guarantee that S2 would be the same as N1. But N2 284 is such a number that S2 is 220, which is the first. Okay, so you can see I have chosen different colors for that. That L12 is N1 by S2. So in blue, N1 by S2, 220 by 220, so it is 1. And in green color, L21 is N2 by S1. So 284 by 2. Again, it's 1. So this pair is, of course, we can call our life partners, a perfect match for. Okay. And now I would end with a brief historical note. This interesting example 220 and 284 was discovered first long back by Pythagoras. And then Fermat, he was also interested and he could find another number, quite big numbers. This one and that one, they are actually amicable numbers or partners. And then the all-time great, this is Fermat, all-time great Euler, he presented 64 pairs of such numbers. This is Euler. But interestingly, all of them, Pythagoras, Fermat, Euler, all of them missed a pair of moderate size, these two small ones. And that was discovered interestingly by only a 16 years old young person of Italy, Niccolo Paganini in 1806. So don't confuse with a famous violinist Niccolo Paganini. This is a mathematician. Well, till date, more than 5,000 amicable pairs so far are available. And let me share with you that my PG students enjoyed a lot exploring those life partner pairs, of course by computation in their Fortran classes. So they have really enjoyed a lot, and hopefully you too have enjoyed this video. I think you will agree that it is interesting. So even if not, thanks for watching. Thank you.